And as we'll be starting with your unit 2. Okay, so in case if you're having any query in your unit 1, okay, when we're solving assignments, you can contact me and you can ask any kind of doubt. Okay, so now we will be moving to your unit 2. So your unit 2 is based upon your load flow studies. Okay, so why you have to perform your load flow study, we'll be seeing in today's lecture. So as per it, today's lecture is a theoretical one. Okay, we won't be dealing with any kind of problem. So mainly the agenda of today's lecture includes the need and the objective of your load flow. After that, what are the important parameters that are included for the load flow studies we'll be dealing with. Okay, so this is your agenda, and we'll be getting into the lecture. So the topic of the unit 2 is power flow analysis. Okay, how power is flowing through your complex interconnected power system we'll be dealing with. Okay, so based upon this only, the many kind of SCAD, okay, that is supervisory control units in the substations are all working out. Okay, in prior to dispatching the load, that is prior to giving the load supply to any kind of industry, what they'll be doing is at the substation with the SCADA, they'll be simulating the uh, presence of load. Okay, what happens if the load is added? If the load flow is not affected, in the sense they'll be adding that, they'll be giving the supply to the industry. Otherwise, they'll be asking the industry to get reduce their load, or they'll be asking them to schedule their load. Okay, so reducing the load is different from scheduling the load. Okay, scheduling the load means, so most of the industries in the India and all, they will be have going for scheduling the load, not reducing the load, because reducing the load in the sense the efficiency and the resources will be degraded. The utilization of the resources will be degraded. But in the sense scheduling the load means based upon the shift. Okay, they'll be saying in the core industries and all, they'll be running in the machines for two different shifts. Okay, one machine will be running for one particular shift and other machine will be running for some other particular shift. So based upon that shift process, you can schedule the load. Okay, and such kind of studies, the primitive process is your load flow study. So this load flow study is the primitive process which involves your load dispatching. Okay, so with respect to this, we'll be first getting into what we'll be getting is, we'll be getting into the objective or the aim of the load flow study we'll be getting. Okay, and over here, so it is very important for planning, controlling, and extract the best performance of existing power system. So this is a default one. Whenever there's an interconnected power system, in the sense you have to, it is the responsibility of the power system engineer to extract maximum power without any disturbance to the other network. Okay, so it is also needed to estimate existing performance of the system and to predict for future. So here the predict for future in the sense, it what it means is, you are having a particular interconnected node. Okay, interconnected power system network. So after a particular period, that is after 2 to 3 years, the city is expanding, and you have to add extra to industrial load to the network. Okay, so while designing the such kind of power system network, the power system engineer should take into account the future extension capability. Okay, that is even if you are adding 2 to 3 or more industrial loads, your interconnected system must be able to withstand and it has to be stable. Okay, so such kind of criteria and all the power system engineer has to consider while designing the interconnected power system, and for that the main thing is that he has to perform the load flow studies. So moving on, so this load flow helps to determine the best size, okay, favorable location of power capacitor. Okay, so what is the need of the power capacitor? So the need of the power capacitor is to improve the power factor. So as I have previously said, most of the loads, okay, nearly around more than 85% of the loads will be of inductive load. Okay, such kind of inductive load, what it does, it will be having always your lagging power factor. So in order to attain unity power factor, so you will be adding such kind of power capacitors. So when you're adding this such kind of power capacitors, possible it is possible to attain, what you can say, it is possible to reach your unity power factor. Okay, and moving on, the bus voltage by means of Q control. So this is all with respect to the quality and the reactive power control. Okay, I'll be explaining it while in dealing with the reactive power control. So next is the load flow studies conducted to determine the operating condition of a power system. Yeah, this is a very important thing. As I said, okay, as I said, there will be some interconnected power system. Okay, so we can, for example, we can take. Okay, so we can take this as a bus one. We can take this as a bus two. Okay, bus one, bus two connected. Here is your generator. Okay, so here is a load, static load, followed by a bus 3. It is also having a static load. So this is a kind of a 3-bus single machine 3-bus system. Okay, and over here what you can see is that why you had to do load flow for this particular network, in the sense, okay, in the sense, you might be knowing the value of your voltage and the power rating of the bus 1, because it is the bus at which your generator is connected. Okay, so this is a simple network. I'm explaining with a simple network. Okay, but in case of bus 3 and bus 2, you don't know the value of your voltage. Okay, your angle del, that is your power load angle del. Okay, so those are the things we don't know. Power you don't know, that is real power you don't know, reactive power you don't know, also current flow you don't know. Okay, in order to find such kind of parameters, you'll be going for load flow. You'll be going for load flow studies. So that's what they're saying. Load flow studies are conducted to determine the steady operating conditions of a power system for a given set of bus loading conditions. Okay, and moving on, so it also gives the initial conditions of the system. So initial base conditions also you can infer from your load flow studies at the period of your transient condition behavior. Okay, so we'll be next moving to the outcome of the load studies. So we have seen about the objective, why we and the need of doing your load flow studies, and now we'll be seeing about the outcome, that is what is the result through the load flow studies. Okay, so the solution of a load flow study provides information about voltage magnitude, as I said, bus angle, okay, real power flow, reactive power flow. So these are the things what I have already said at each node. So here nodes represents bus, and you can take nodes or it is bus and individual transmission line. Okay, and individual transmission line losses also it is possible to infer from your load flow studies. So these are the outcomes. Okay, these are the outcomes of your load flow studies. So next is the four important bus quantities dealing with the load flow studies are magnitude of voltage. So here you have to be very clear that we are saying about the magnitude and phase angle as two different parameters. Okay, you shouldn't be taking those two as a same single parameter. So the magnitude of the bus voltage is different from that of the phase angle of the voltage. So the phase angle plays a very important role in your power distribution system. So if the phase angle deviation is very high, okay, the power system stability will fail. And what happens? It will be resulting to the blackout. It will be resulting to the blackout. Okay. So this is a very important parameter. Okay. Even at 2015 or 17, I think New Delhi faced out entire blackout. I think South New Delhi faced out an entire blackout. So it was mainly due to this phase angle parameter. So you might be thinking this is a simple parameter, but it has a very higher impact over their power system network. Okay. So next is the real power. So this will be based upon the load what you are connecting, and then the reactive power. So reactive power is nothing but the if you are connecting a more amount of inductive load. So that inductive load has to be in need of some storage power. So such kind of storage power is provided through your reactive power. So these are the four important quantities revolving around the load flow studies. Okay. So next we'll be coming to the types of bus. So regarding the type of bus, I have already dealt in the unit 1. Okay, we'll be again seeing it. Okay, each bus in a power system is associated with the four quantities that we have previously seen. In a load flow problem, out of four, two quantities are specified and the remaining parameters are to be determined. So this is the template at which the load flow problem will be. So in your load flow problem, as I said, at the can be coming to the template of this problem itself. So here, as I said, you might be knowing about the data of your bus 1. Okay, but you won't be knowing about your bus 2 and bus 3. That you have to calculate. So at that period, you might be knowing about any two data of the bus 1. Okay. So in the load flow studies will be like that only. That is, they'll be giving any two quantities, and based upon the quantities, you have to find remaining parameters. Okay, through power flow equations, you have to arrive at the. So depending on the quantity specified, the buses will be classified as PV bus, PQ bus, slack bus. We have already dealt with this. So PV bus is generally a generator bus. So PQ bus is a load bus. So slack bus we will be seeing now. So slack bus is nothing but your reference bus. So based upon the reference only, you will be selecting your common base MVA and common base KV. Okay, the slack bus voltage and power will be taken as a common base MVA and common base KV. Okay. So next is the purpose of the slack bus. Next is purpose of the slack bus. So why we are seeing about slack bus is that so it is that is the real power injection into the bus will be known for your PQ and PV bus. That is the other two buses. Okay. The transmission line losses are unknown until the load flow solution. Hence, one of the generator bus will be considered to be a slack bus. So what they are saying is that the main purpose of the slack bus revolve around to be the reference value. So before getting into the load flow, you have to form your Y bus matrix. Okay. So when you're forming a Y bus matrix, if you are not knowing any kind of the per unit value in the sense, if you don't know any kind of per unit value in the sense, it is you who have to find the per unit value. Okay. So for finding the per unit value, you have to know the value of the common base MVA and common base KV. And for that purpose, one generator will be taken as a slack bus. Okay. Whereas the real power injection will be dealt by your PQ and PV bus. I hope you're clear with the bus concept. So the three buses, it's very important. So the slack bus supply additional real and reactive power. Okay, additional real and reactive power is by the supplied by your slack bus. So to account for the transmission line losses, as I said, generally you know that your input will be always equal to the summation of the output plus your losses in any kind of your electrical system. The same thing occurs over here. So here your generated power will be equal to the distributed power plus the losses. Okay, so but this losses will be only calculated if the value of the power factor is given, because based upon the power factor only the real power will be always revolving. So we might not know about the type of load. So not to know about the type of, otherwise in some problem they will be giving the type of load without specifying the power factor, then you have to consider it. So coming to the selection of slack bus. Okay, coming to the selection of slack bus. If the selection, if the slack bus okay, so if the slack bus if the slack bus is not specified, then generator bus with maximum real power is taken as a slack bus. Okay, so here they're saying sometimes the question is that they won't be giving you the value of the slack bus, then you have to consider the generator bus with the maximum real power. Okay, there may be more than one slack bus due to complexity of the network. Yeah, this is possible, because in case of your IEEE buses, so you just Google about this IEEE buses. So there is a large amount of IEEE buses. For example, you can take IEEE 14 bus system. In an IEEE 14 bus system, there might be any two bus of same rating. Okay, any two bus of same rating, and both the buses will be of a very high maximum real power they might be having. Then in such an interconnected network, it is possible that there can be more than one slack bus. Okay. So the bus admissions matrix is generally used for the load flow studies. Why it is used? For the following reasons. That is, the first thing is the data preparation is very much simple if you are using your Y bus. The bus admittance matrix can be easily formed, so as you know it already, and modified for network changes in addition to the transmission lines and regulation. Okay, that is what they're saying is that even if there's any kind of changes in your network, with the help of the bus admittance matrix, it is very easy to identify, and you can change the value. Next is the sparsity of the bus matrix is the greatest advantage. So you might have studied about sparsity in mathematics. Okay, so that is what you can say, that is, if you are having the sparsity will be generally revolving around your identity matrix. Okay, so I won't be getting into it. You just refer with respect to your uh, sparsity. Okay, so this reduces computer memory in case of your computational time requirements. Okay, the load flow studies will be basically done in your computers. Why in the sense means there will be more than actually for study purpose, theoretically we are making use of a 3 bus system, 4 bus system, or 5 bus system. But basically, if you are saying in the real time, the interconnected power system network will be very high, very it consists of a enormous number of buses. Okay, it consists of enormous number of buses, and it is necessary to check through all the bus. Okay, so it might be get somewhat difficult, and for that purpose, we'll be making use of your Y-bus matrix. Okay, so moving on, another one advantage of this Y-bus matrix is the symmetricity property. You already know that. So, and hence based upon this, it will be very much easier for you. Okay, and this is with respect to your second unit first lecture. Okay, so I'll be stopping with this. Okay, and so if you're having any doubt, you can just ask me with